So homework 3 here, Math 146. We're going to look at odds in favor, odds against, and we're going to look at use of our sample spaces. Okay. If the probability of an event B occurring is 7 out of 10, that is 7 successes and 10 failures, we have 7 wins, and we have 10 total. And so if we go 10 minus 7 equals 3, we have 3 losses. And whenever you're dealing with odds, you're dealing with a combination of wins and losses in a ratio. What they ask for will determine the order that the ratio goes in. Odds in favor of B means give me the good before the bad. So here the odds would be good is 7 and bad is 3. 7 over 3 or 7 colon 3. Odds against would be with the 3 coming before the 7, 3 to 7 or 3 over 7. Now we're going to look at 2 dice. What are the odds when a player does this? Now every time we roll dice, 2 of them were among those 36 opportunities for the outcomes. That's our sample space made up of 36. So here we go. Total possibility equals 36. In favor of a sum of 10. Sum of 10. The first 10 I have is something that has a 4 as one of its dice. You can't do it with a 1, 2, or 3 on one of its dice. 4, 6, 5, 5, and 6, 4 make 3 of them. So we'll have wins equals 3, losses equals take 36 minus 3 and we get 33. So our losses are 33 and our wins are 3. In favor, give me the wins first. That can be 3 over 33, also known as 3 colon 33, or you might have 1 out of 11. Against a sum of 4. So now we're going for the sum of 4 where the total is 36. 4s. We can go 1, 3, 2, 2, 3, 1, then we're off the board. We get only 3 of those. So this turns out to be having wins also being 3. So losses is again 36. And this time we subtract 3 ways to make 4. We got 33 that are bad. Odds against, that would be 33 first, followed by the 3. Or 11 over 1. Even 11 might be what we're looking at. But 33 on top of or in front of 3 is acceptable. It's 11 to 1 against. Odds against doubles. Doubles are when you have the same 2 outcomes on the 2 dice. Here they are of different colors. 1, 1, 1, 2, 1, 3. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Each of those 6 numbers shows up as a pair. So here, with a total equaling 36, and wins, there are 6 ways to make doubles. Losses, 36 minus 6 will get you 30. This is against, so it wants the losses first. It wants the 30 on top, the 6 on the bottom. Commonly known as 5 to 1. 30 over 6, 30 to 6 will work, 5 to 1. 1 out of every 6 rolls, probability, means that we're going to have 5 losses, that's the top, for 1 win, which is the bottom, when we go for against. A 52 card deck, we're not looking at this. We're not looking at the orange, which is labeling our columns, but the black, blue, red, and green. In favor of getting a black card, the clubs are black and the spades are black. I did them in different colors here so you could see them on our list, but clubs and spades are black, hearts and diamonds are red in the deck. If you get my printed version of the sample space in color, you can see. If you print it on black and white, it's hard to tell, but when you look at it or print it in color, you'll be able to see that the black cards, there are 13 that are clubs, plus there are 13 that are spades out of the 52. That's 26 out of 52, which is acceptable. It actually reduces to 1/2. Because 1 out of every 2 cards, when you look across the entire deck, would be a black card. In favor of getting, so this is odds, that's probability. Interesting. We'll take that same information, but we'll take our wins, 13 plus 13 for 26, total equals 52, losses equals 52 minus 26, get you another 26. So now we go in favor of getting a black card. Winning is 26, losing is 26. That's also known as 26 over 26, or 1 to 1. A lot of people call it 50-50. There aren't 50 fitting here. 26-26 works, 1-1 works, people saying it even. That's all good. Favor getting a jack. How many jacks are there? 1, 2, 3, 4 J's in the entirety of this deck, which is made up of 52. So the total is 52. Wins is the 4 jacks. Losses. Take the entire deck of 52 and subtract your 4, you get 48 losses. And favor wants the good stuff first. So odds in favor, good is 4. Let's write that 4 so it's easily readable. 4 followed by losses of 48. That is 4 over 48. Acceptable that way. 1 out of 12. 1 win versus every 12 losses. So the odds in favor of getting this jack are 1 in 12 or 4 in 48. Against getting a club. Club this entire top row of 13. There are 52 in there. Wins equals 13. Total equals 52. We have the total. We subtract what we know to be winners, and we can see 39 for losers. So we can say losses is 39. Now those are ready to go against. That means bad news first. Give me the 39 first, followed by the good news of winning 13. That's 39 over 13. If you divide each one by 3, by 13, you see that this gets you a 3 to 1 against you getting a club. 3 times you won't get a club for every 1 time you will, because 1 out of every 4 actual cards in there is a club. That means 1 time you win by getting the club for every 3 that you lose, and they ask for the losses first, so it's called 3 to 1. One more coming here on homework 3. This is a problem that every semester students groan about. So unless you hit me up during our weekly talk to complain about it, I actually won't hear the complaints this semester. Maybe you'll email me about it. This is a problem that students find challenging. It's a multi-step problem. They think, oh, let's whine about it. Knossos will take it off. He seems to be a good guy. I'm not taking it away. You're going to see this on quizzes. You're going to see this on exams. So you may come back to it when you see it in more than one homework. It appears in more than one homework because a lot of people think, I'll just duck it this one time, no problem, and I don't have to deal with it. It is a multi-step problem, and so it takes multiple steps. Here's the story. We want to find the probability of each formation of a committee on a campus. Now, 4 people are going to be on the committee, and there are 19 students who might make the committee and 7 faculty members who might make the committee. So what happens is, for the big one, we're going to have that n is equal to 19 and 7, 26 people to make up the committee. And R is how many, 26 people are going to be drawn from to create the committee. Only 4 of them will make it to the committee. So now we're dealing with a combination of people who make it to the group. These are all combinations. So we're going to need this 26, choose 4. And you may use your technology. The best technology that you're comfortable working with is allowed on this that we're using. So once you know it's 26, choose 4, then you can go ahead and get that. I'll do it without much technology. Here we go. 26 factorial, 22 factorial, 4 factorial, which is 26, 25, 24, 23, and 22 factorial. Here we got 22 factorial and 4 factorial. I will take that out. And so this is where that's got to go. 26, 25, 24, 23 over 4 times 3 times 2 times 1. So, you know, I'm going to take 4 divided by 4, 24 divided by 4, get me 6. 3 divided by 3, get me 1. 6 divided by 3, get me 2. 2 divided by 2, get me 1. What we're left with here is 26 times 25 times 23. And that's the denominator. That's the denominator of each of our answers. So we're going to see that every time the denominator is 26, choose 4. That's about people, not about who's what kind of person. So 26 times 25 times 23. And I got it. 14950. It's the denominator of each one of these. So let's get after A. The denominator is 14950. The top is all faculty. I'm going to do, since they show up here as students then faculty, I'm always going to do the student number first and then the faculty number. And let me set you up for what that's going to be then. You got a combination with 19 students choosing none, multiplied by 7 faculty choosing 4. For B, we have a combination where we have 2 faculty and 2 students. So 19 students choose 2, 7 faculty choose 2. Over 14,950. C, we have all students. So we have 19 students choose 4 and 7 faculty choose 0 over 14,950. D, 1 faculty member, 3 students. 19 students choose 3 times 7 faculty members choose 1 over 14,950. And E, you may not get the first one, but by the time you get to the 5th, I'm sure hoping you figured it out by trying it through, not just watching me do everything when you do your work on this. You can get your combinations using your technology, but you've got to set it up where we've got the faculty contribution multiplied on the top by the student contribution. It doesn't matter which is first or second. On the bottom, we got the people definition of a committee, which is the same every time because we're always drawing. 26 people are giving us 4 of them to be on the committee. So we have 19, where we're going to choose just 1 student, and we have 7, where we're going to choose 3 faculty. That's 14,950. Okay. So you can go through, and there are lots of them that demonstrate how to get these values. So I know that 19 choose 0 is going to be a 1 times the number there. These we got to come back and deal with. This is going to be some number times a 1. It's going to be over 14,950. It's going to be 2 numbers that are going to be over 14,950. It's going to be 2 numbers over 14,950. It's going to be 2 numbers over 14,950. I'll come back and I'll do my multiplying later because I want to get these guys done. I want to get my combinations completed. So on top, you can do 19 choose 0 out and find that it's 1, but I got to do 7 choose 4. So here we go. 7 math. Let's choose 4. 35. 35 over 14,950. Okay. Next I need 19 choose 2. 19 choose 2. 171. Times 7 choose 2. 7 choose 2. 21. Let's figure out what that's going to be. 171 times 21. 3591 for 14,950. I got the 1 there for 7 choose 0, but I got the 19 choose 4. $38.76 times 1. Okay. Now, 7 choose 1 is 7, 19 choose 1 is 19. You can figure them out working the formulas or your technology if you want. But I need 19 choose 3. 969. choose 3. Alright, I got 35 times 19 to deal with down there. 665. Now, because it has 0 faculty, 1 faculty, 2 faculty, 3 faculty, so let's try to get 0 faculty, 1 faculty, 2 faculty, 3 faculty, and all 4 faculty, everything is covered. Therefore, my numerators should add up to 14,950. Let's see, 35 plus 3591 plus 3876 plus 6783 plus 665, enter. That's perfect. They are all represented somewhere. Now, let's go find the probabilities as they show up. And this will be your opportunity to work on rounding if you have any trouble with decimal rounding, which is something you should have brought into this course already. Here we go, 35 divided by 14950, and I hit enter. I'll go 0.002, 341. 0.002, 341. 41 does not go up to 50. And therefore, I'm going to keep that as 4. If the 41 was 45 or higher, I would turn it up to 5. Okay, 3591 divided by 14,950. 3591 divided by 14,950. Enter. 0.240, 220. 0.240, 200. Okay. Now, 00 does not go up to a higher number, so I'm going to knock off that 0 without pushing the 20 up to 21. 3876 over 14,950. 3876 divided by 14,950. 259, 264. 259, 264. That's close. 64 almost goes up to 70, but it does not. Somebody better round up, or it's not going to show you guys how to round up. All right, clear. 6783 divided by 14,950. 453, 712. 12 does not go up to 20, so I'm going to turn that into 45371. Come on, guys, we need one that works. 665 divided by 14,950. 0.04481. That's 0.044, 3 fours, 44481. Well, that's terrible as far as demonstration purposes, but what's going to happen is that 81 does not become 90, and that becomes 8. I think this is actually going to come up short of being where it's got to be. When I add my last digits, I get a 4 and a 0 and a 6 for 10, and that makes 11, that makes 19. It's going to come up just short. They were all rounded down. If the 6th digit, the digit beyond where I'm rounding, is 5 or greater, such as if this thing said 267, then the 67 would become 70, and then you lose the 0 and do that. None of that happened in this. They all went down, but that's how rounding works, and you are accountable for knowing how to round. So you look one digit past where you're rounding, you treat it as a 2-digit number that includes that as its final digit. If it rounds the number up, so be it. If it rounds it down, so be it, but then you drop the 0, so you don't wind up with the 6th digit, you only wind up with 5. Here it is, you may be back at it several times when you're looking to prepare for a quiz, then again for another homework or something, or maybe in a review, or ready for the final, or ready for any exam. But this one, I suspect, the end of homework 3, will be a lot of looks throughout our semester. You can ask me about it, it's fine. If you want help learning how to round, I can work with you on that during our sessions. You should know how to round when you leave this class. A lot of people think you should have known how to round when you come in, but I don't have any control over that. So if you don't know how to round, that's an expectation of your ability by the time you leave this class. All right, one more.